Hello everyone, welcome to the lesson for 6.8 for CTM. Today we're talking about linear inequalities in two variables and specifically graphing those things. A half plane, we'll talk about that as we do the examples. That's really the only new term that gets thrown in here. So there are some steps, there's an algorithm, a procedure that's going to work for us that I want you to follow every time you have to do something like this. So here are the steps to graph inequalities in two variables. Our variables generally will be x and y, but they could be other letters as well. So here's the steps. These are the steps that I want you to follow every time. It'll make it real easy to graph things like this. So step one, this I think is the easiest way. The book doesn't necessarily put it exactly the same way I do. The book gives you a different way to do this, but I think this, personally, I think this is the easier way to do this. You can do what the book says to do or follow those steps instead, but I'm going to show you this way. If you want to check out the book's way and you want to do it that way, go ahead and do that way as well. So I would recommend first that you get the inequality in slope-intercept form. And so notice I've given an example here. This one happened to be in slope-intercept form. This is y. Instead of equals, we'll have our inequality sign. So y equals 2x minus 5. It's just like that, except we have greater than or equal to instead of just equals to. So we have y equals mx plus b. It's still in that same form. So we want to get it in that form first if it's not already in that form. And you'll notice I have graph paper here. Hopefully you notice that. If you have your own graph paper, it would be a good idea to do the notes on graph paper because we're going to be drawing some careful graphs. If you have started already, we haven't gotten too far into it, so I don't think it would be too problematic to switch to graph paper. I would highly recommend that if you have some graph paper. Step two, though, you're going to plot the line, or graph. Graph is the same thing as plot, another way to say that. Plot the line as if it were an equation. So just like we learned before, the previous lesson, we were graphing lines in the previous lesson in 6.7. We're going to do the same thing here. So it's really nothing new except for this shading part. But make the line and this one little thing here too. So the line could be solid or dashed. Kind of depends on the sign. So make the line, it doesn't kind of depend on the sign, it totally depends on the sign. So make the line, but make the line solid if the sign is less than or equal to or greater than or equal to, and dashed, or hidden you might say, if the sign is less than or greater than, strictly less than or strictly greater than. And then the third step, the final step, you just need to shade above the line. And we'll talk what I mean by that, shade above the line. Here, think of the line as kind of a roof to a house or a building, and what would be above the roof? Well, it would be this stuff. You're shading above the line here. So notice this is greater than or equal to. We're shading above the line if the sign is greater than or equal to. Remember though, it has to be in slope-intercept form. If you're going to use the steps I'm showing you here, it's got to be in slope-intercept form first. And below the line, below just meaning underneath, think of it as a roof again, below the roof. The roof. How do you say it? Tomato, tomato, huh? Below the line, I say roof most of the time. Maybe that's because I'm from Michigan originally. I don't know. If the sign is less than or equal to. And so if you follow those three steps, I think these problems are going to be really easy. It'll take a little bit of time because we'll have to draw some careful graphs, but I don't think they're hard. So example one, draw the graph of y is less than 1/2 x minus 3. Make sure you don't write the x underneath the fraction bar, and keep your fraction bars vertical. Don't write this off to the side here, just kind of listen. If you write your stuff like this, I can't tell if you're saying that this is the same thing as 1 over 2x, or if it's supposed to be 1/2 x, like that. Which one are you doing? I don't know based on what you wrote here. So don't write your fractions like this, where you have a slash like that. Don't use that for fractions. Go straight up and down. This is what we're looking for. We're not looking for this. So 1/2 x, write your fractions like that for me, please. And this, let's look at step 1. Get the inequality in slope-intercept form. Now look at this, and it's already in slope-intercept form. So I do not need to do anything for step 1. I'm going to write that it's already in slope-intercept form. So beautiful. Step 1's done. I didn't even do anything. That's nice. That's always nice, right? You didn't even do anything and you got paid for it, something like that. Wow. Where is that job? I don't know. All right, here is going to be your slope. This is your slope. Remember, this is in slope-intercept form, so the slope is the coefficient in front of the x. Your intercept, it includes a sign. It's always the number, the constant term after the x part here. So the slope, this is another way to say that you're going up 1 and right 2. Rise over run, remember. So you're going, this is the vertical part, the vertical change. If it's positive, it's up. If it's positive on the bottom, it's right as well. And then with this, if we look back at our steps here, if it's not or equal to, it's going to be a dashed line. And so let's just make a note of that. It's going to be a dashed line. And we're also going to shade, because it's less than, look at step 3 here, we're going to be shading below, because the sign is less than or equal to. So we're going to shade below. So we're going to take what we've done here in words and translate it into a picture down here. So I want you to draw a very careful graph. If you have a ruler, please use that ruler and measure things. If you have graph paper, that makes it a lot easier. We can see the graph a lot more clearly that way. But if you don't have graph paper, use a ruler. Make sure these markings are equally spaced, otherwise your answer will be thrown off. So let's go 5 in each direction. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not time to leave yet. Pay no heed to that bell. So here's my graph. Put my arrows because this goes on forever and ever and ever. Forever. This is x. This is y. We're going to say each one is just 1. So where's your y-intercept? It's at -3. So we're going to go on the y-axis and find -3. That's where it crosses the y-axis, where the y-intercept is. So there's your point to start. So start there. And then from that point, we can get another point by easily going up 1 and right 2. And you go up 1 and right 2, you got a new point. Do that again. Up 1, right 2, another point. And that pattern would continue. You'd have another point right here. If you went the other direction, you'd go down 1 and left 2, and you'd get another point down here. So at that point, let's draw a dashed line connecting those. I think I have a tool that will do that for me somewhere. Do a dashed line instead. There we go. I think that should do it. And so my dashed line would look like that. And then I would be shading in a certain direction. Let's use our different color for the shading. What direction am I going to shade? So I got a dashed line. We're shading below because its y values are less than the 1/2 x minus 3. So shade below, doing something like that to represent that. And then this is where I can throw in the one new vocabulary term here. This plane, the Cartesian plane, the Cartesian coordinate plane, is getting cut in half in a sense by this line. So we've got half of that plane down here, half of the plane would be here. It's not really half and half because it goes on forever. Can you take half of infinity? What is half of infinity? I don't know. That's a confusing thing to think about. There's people that do that for a living that talk about and think about infinity and what that all means. Interesting stuff, I think, but this is a half plane. What the part here would be shaded would be called a half plane. The part up here that's not shaded would be the other half plane. It separates it into two separate half planes in a sense. Let's check out a second example. Okay, so let's see what we got here. It says to draw the graph of negative 5x minus 4y is less than or equal to negative 8. And shame on me, I forgot to say one thing back here that I meant to include. So to talk about the solution and what a solution would be for this one, let's make this note. Any point in the shaded part but not on the line. Why can't it be on the line? Well, it's a hidden line. It's a dashed line. It's not actually including the points on the line. It has to be strictly less than. That's another way to think of it. So it's everything lower than that but not actually on the line. So any point in the shaded part but not on the line is a solution to the inequality. And so what that means is, let's say we picked a point, 3, negative 3. If I plug that in up here, I'll just do that mentally. Why don't I pick 4, negative 3? A little easier to deal with the 1/2 fraction like that. So let's say I picked 4, negative 3, point right there, and I plug that in mentally. I've got 4 times 1/2 would be 2, and 2 minus 3 would be negative 1. My y value here is negative 3, so I would plug that in here. Is that true? Is negative 3 less than, when I plugged everything in here, I got negative 1. Is negative 3 less than negative 1? It sure is. So that's a good way to check your answer. Find a point that's actually in the shaded part, plug it back in, and see if it makes it true. If it makes it true, you know you got the right thing. Or you're pretty confident at least, unless you messed up the line. Then we've got some other issues. So double check your line, but you can check your answer pretty quickly as well to see if it's a reasonable solution by picking a point in the shaded part. Alright, let's do example 2. Let's continue that now. So we've got this. Step 1, remember, is to get that into slope-intercept form. So it is not in slope-intercept form right now. Let's change it so that it is. So I would add 5x to both sides first. Let's show the steps in the different color here. That would cancel. Left with negative 4y is less than or equal to 5x minus 8. From there, divide by negative 4. If you divide one thing by negative 4, you got to do that to everything. And so the negative 4's will cancel. I'm left with y. But notice I divided by a negative. Remember what we do to the sign then. We have to flip this sign. So we have greater than or equal to now negative 5/4 x. Again, write your fraction straight up and down. Put the x after that, kind of in the middle. That way we know it's not on the bottom. And you have negative divided by negative will make a positive. 8 divided by 4 will make a 2. So this now is in slope-intercept form. That's, I feel like, the best way, the easiest way to do this, to get it into that form first. And so now let's determine what we can tell from here. This is in slope-intercept form. So that's good to go. And this value right here, that is, I'm going to write slope. What am I doing? This is my y-intercept. So my y-intercept's at +2 or +2. This is my slope. I always include the negative with the top part. It just makes it easier because that way I either go up or down, and I always move to the right after that if I have my bottom part positive. And then this right here is going to mean I have stuff greater than, so I'm going to shade above, and it's or equal to, so it's going to be a solid line as well. So this is a solid line, and we're going to shade above based on what we talked about in the algorithm in the 3-step procedure back here. So we got this shading above since it's greater than or equal to, and we're going to make it solid since it's or equal to. So from there, let's draw our graph. Draw it carefully. If you have graph paper, awesome. If not, draw it very carefully. Draw your points, your spaces equally apart. Use a ruler to do that. So here we're going down 5 and to the right 4. Going down 5 because that is negative right there. Down 5, right 4. And let's draw our graph. We'll go 5 in each direction. Again, actually, we're going to go a little bit farther. Let's go 7 in each direction with this one. Let's go 7 in each direction. So I'm going to go here. I've got that. Yep. So that looks like it'll be enough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. And then halfway there, I've got, looks like that's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, I went 7 in each direction. Got it. Count it. And the foul. That wasn't a foul, ref. What are you talking about? Hey, don't worry. I love basketball. I've got basketball on the mind. NBA playoffs are going on right now. Go Spurs. Beat the Lakers. Woo! I've got... I'm living in California, but I'm still not a Lakers fan. And go Clippers, all right? Pistons aren't playing in the playoffs anymore. They've had a rough few years, so I'm just going to say go Clippers. I'd rather see them win than the Lakers for sure. It's just how it is. I'm sorry. So we've got the y-intercept is at +2. That's right there. And we're going down 5 and right 4 to get a new point. So down 1, 2, 3, 4, 5. Just count carefully. 1, 2, 3, 4. So you've got a new point right here. If I don't label these, just assume that each one is 1. If I went up 5, I would have to make this part negative instead. I would have to go to the left 4 to make sure that's a straight line. So if I went up 1, 2, 3, 4, 5, this is why I went to 7. And I go to the left 4. And if you do this right and you connect the 3 points, they should form a perfectly straight line. If you've got a carefully drawn graph, that's going to happen. And so we've got that here. Let's draw that, and looks good. One thing though that I don't want there, should that be hidden? No, it should be a solid line. So that was my fault there. I want to change that to the solid line part. There we go. So we've got a solid line, and we're shading above, so I'll get out the different color there and shade above here. There we go. So we're shading this way because we're talking about y values that are greater than -5/4 x plus 2 values. So all this stuff getting shaded here. So here's your half plane up here that's shaded. The half plane that's not shaded is down here. And to talk about the solutions here, just like before, we had any solution in the shaded part was a solution to the inequality, any point in that part, but not on the line here because it was hidden. Here it's the same idea. Any point in the shaded part is a solution, but because the line is solid, you could also be right on the line. Those would be acceptable values, acceptable solutions as well in this case. So any value in the shaded part or on the line. What is that? Oh, on the line, there we go, is a solution to the inequality. So anything in here would work, anything on the line would work. If you plug in some values, I would say plug them into the original equation and then see if that makes it true. We won't do that here for time's sake, but you can do that here. You can pick a point, any point in here, plug it in, see if it works. And then example 3. What if I gave you something that looked like this? Well, if I did, you should not freak out. It's actually the easiest one we've done so far. Draw the graph of y is greater than x. You might say, well, is that in slope-intercept form? I don't think so. Where's the numbers? I'm confused, Mr. Wagner. Hold on. Calm down. Okay. This right here is the same as y is greater than, what's the slope here? What's the number in front of the x? Well, it's like there's a 1 in front of there, which you could write as 1 over 1. So I'm going to put that in the different color. there's no value after the x, that means it's like it's plus 0. And so that's the other way to think of it, the way that puts it into quote-unquote slope-intercept form. So now this is in slope-intercept form. So now we got what we need. Our slope is right here. And that means you're going up one and right one to get a new point. Both positive ones. Your y-intercept is right here. It's right at 0. It's right at the origin. And this just means that you're shading above, and it's a dashed line because it's not or equal to. So dashed line, and you're going to shade above. And so from there, let's draw our graph. This one, let's just go 5 in each direction. That should work just fine for this. And we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That'll work there. And now let's plot our points. So we've got a point at 0 on the y-axis. This is x, this is y. I think I might have forgot to do that one. We'll do that in here. Yep. It's always a good idea to put that. Just as a reminder to yourself, that's the x-axis, the y-axis. And we've got a point at 0, 0. If you go up one and right one, you got another point. That pattern is going to continue. So you can keep going up one and right one, get new points. If you went the other direction, down one, you'd have to go to the left one to get new points. So that pattern will continue this way as well. This would be a dashed line. Connecting all those dots. And we are shading above. I meant to circle that over here. Hey, red please, thank you. Shading above that. So think of this as a roof to determine what's above and below. So the people would be happy and dry underneath the roof here. The rain would be coming down and hitting the roof like this here. So that's above that. And just like before, anything in the shaded part would be a solution to the inequality. Anything on the line, since it's dashed, would not be included in the set of solutions. Anything under here, definitely not a solution, not part of the shaded part. And so that's going to do it for me here. Just had 3 examples there, and I think that should be totally sufficient for what you need to do well on the classwork for those problems. So check it out again if you need to. Go back and review, rewind as necessary. I hope you do well in this lesson. Let me know if you have any questions in class, as always. And hey, have a good day. I'll catch you guys later.